Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss radioactivity, law of radioactive decay, half-life and mean life. Let's begin. Radioactivity. This is the phenomenon of spontaneous emission of radiations by heavy elements. Elements whose mass number is greater than 210 is called radioactivity. Why the phenomenon of radioactivity occurred? As we see, in case of nuclear stability, as the graph between n and z means the neutron proton ratio concept is useful to understand the stability of nuclei, and those nuclei are unstable. They try to be stable by emitting some kind of radiations. So, the phenomenon at which these nuclei, unstable nuclei, emit radiations spontaneously, that phenomenon is called radioactivity. And those elements that perform that type of phenomenon, we call them as radioactive elements. The elements those under this phenomenon are called radioactive elements. Some examples of such radioactive elements: polonium 82 PO 210. This is atomic number, that is mass number. Radium 92, radium 226. Uranium, whose atomic number 92. Thorium, atomic number 90. These are some examples of radioactive elements. Those show the phenomenon of radioactivity, means spontaneously they emit radiations. Those nuclei are unstable, they try to be stable. These are show radioactivity due to emitting alpha, beta or gamma rays, and that process is called radioactive decay. Thus, nuclei those are unstable, they show the phenomenon of radioactivity. How that phenomenon occurred? Due to the emitting such type of radiations, alpha, beta or gamma radiations, and that type of process is called radioactive decay or radioactive disintegration. Some basic properties of alpha, beta and gamma. Alpha decay, in which alpha is a helium nucleus, doubly charged helium nucleus 2He4 is emitted in that decay. Beta decay, in which electrons or positron are emitted. Electron -1 E0, that is negatively charged, and we represent it as beta minus. Positrons +1 E0 represented as beta plus. Positron as same to that of mass of electron, but it charge is positive, opposite to that of electron. Next, gamma decay, in which high energy photons are emitted. The photon of energy, let h nu, whereas h be the Planck's constant and nu be the frequency of such gamma ray radiation. These are some basic ideas of alpha, beta and gamma decay. Due to this decay, these unstable nuclei show radioactive decay. Next, law of radioactivity. radioactive decay occurred. So, mathematically how that phenomenon occurred? According to this law, the rate of disintegration, that is the number of atoms disintegrating per second, rate of disintegration rate, that is the number of atoms disintegrating per second of a radioactive sample at any instant is directly proportional to the number of atoms present at that instant. Let us prefer, let dN be the number of atoms that are disintegrating in a time duration dt. In dt time, let dn number of atoms are disintegrate, and so total number of atoms present, and n be the number of atoms present at that instant. Then according to that law, the rate of disintegration, that is the number of atoms disintegrating per second, here we choose dn number of atoms disintegrating in time dt. So, the rate will be dn by dt, which is directly proportional to the number of atoms present at that instant. At that instant, what will be the number of atoms present? In that of situation, we prefer n be the number of atoms present at that instant, that is directly proportional to n, or dn by dt is equal to constant lambda n, equation number 1, where lambda, that is called decay constant, or we call as disintegration constant. Why we use negative sign? That negative sign indicates there is decrease in that of number n within time. Negative sign indicates the decrease of n in time. Let we integrate both sides with proper limit. Integrating both sides with proper limit that is when time t is equal to 0, the number of atoms let initially present n0. At time t the number of atoms that is n. Therefore, we integrate that integration dn see here n to this side, dt to that side. So, dn divided by n is equal to minus lambda dt. So, dn divided by n is equal to minus lambda integration over dt. Here the limit of that n initially when t is equal to 0, that is n0. After time t, the number of atoms n. Here initial t is 0, after time t, the limit is used in that of integration. dn by n integration, that is log n B.SC, the limits n0 n minus lambda integration of dt t 0 to t, upper limit minus lower limit. So, log n B.SC minus log n naught B.SC is equal to minus lambda upper limit minus lower limit, that result as t, or log a minus log b, log a by b B.SC minus lambda t. Therefore, n divided by n naught logarithm to this side exponential e to the power minus lambda t. Therefore, n is equal to n naught into e to the power minus lambda t. So, what that value of n? N we prefer, that is the number of atoms present at that instant. So, at that instant means at time t, what be the number of atoms are there? Equation number 2. This equation gives the number of radioactive atoms, the number of radioactive atoms left after time t. After time t, what is the number of atoms are left? The number of atoms, number of radioactive atoms left after time t. If we plot a graph, in between time and n, initially n0 when t is equal to 0, and gradually it decreases exponentially, and which is meet at infinity. This one is the law of radioactive decay. The rate of disintegration of radioactive sample at any instant is directly proportional to the number of atoms present at that instant. Mathematically, n is equal to n naught e to the power minus lambda t, that is the number of radioactive atoms left after time t. Graphically, we show it. Next, half life. What is half life? The half life of a radioactive substance is defined as the time during which the quantity of radioactive substance is reduced to half of its original value, then it is called half life. The time required to reduce the radioactive substance to half of its original value is called half life. Mathematically, it can be easily calculated. For this condition, when t as t half, that is half life, then that sample n reduces to half, is n naught divided by 2. Therefore, putting these substitutions, these values in equation number 2, we have in that of equation this n is equal to n naught e to the power minus lambda t, n is equal to n naught e to the power minus lambda t. Now, the condition is used in place of n, that is n naught by 2 is equal to n naught e to the power minus lambda in place of t, that is t half, or n naught cancelled out, half e to the power minus lambda t half, or one by 2, that is 1 divided by e to the power lambda into t half, or e to the power lambda into t half is equal to 2. Therefore, lambda into t half is equal to log 2 of B.SC, log 2 of B.SC. Calculating that value, when that base will be 10, that is 2.303 log 2 base 10, value of log 2 base 10 2.303 into that logarithmic value 0.3010, multiplying this we have 0.693, then t half is equal to 0.693 divided by lambda. So, what is lambda? Lambda, that is the decay constant or disintegration constant. This is equation number 3. From this expression, the half-life of a radioactive substance, is inversely proportional to its decay constant, to its decay constant. So, half life of radioactive substance is inverse proportional to its decay constant. If we plot a graph in between time and n, initially that is n naught, and gradually it will decrease and meet at infinity. So, at time t half, that is reduces to half of its initial value, that is n naught by 2. Mathematical expression for half life. And half life of different radioactive substances are different. Half life of different radioactive substances are different. Taking an example, half life of radium, T half of radium 1590 years. At the same time, T half of uranium around 5000 million years. So, different radioactive substances have different half life. Whereas half of its original value disintegrate. So, that lifetime we call half life mathematically, that is calculated. Next, mean life or average life denoted by tau. The mean life or average life of a radioactive substance is defined as the ratio of sum of life of all the radioactive atoms to the total number of such atoms present in it. So, mean life mathematically total lifetime of all the atoms divided by what will be the total number of atoms. So, tau is equal to the total lifetime of all the atoms. How it is calculated? At a time t, the number of atoms disintegrate in time dt is dn. dn number of atoms are disintegrate at time t. So, time for all the atoms which are under disintegration, that is the total time, when multiplied to that of t and integrating it with proper limit, we have the total lifetime. In that of situation, we choose the magnitude of dn and integrating it from the limit 0 to infinity. divided by total number of atoms. Here is total number of atoms, n naught with the total number of atoms present initially. Therefore, tau is equal to integration from 0 to infinity t, the value of dn as the value of n as n naught e to the power minus lambda t, its magnitude, divided by n naught is equal to integration over 0 to infinity t into differentiation of that one as n naught minus lambda e to the power minus lambda t, it's into dt, its magnitude, divided by n0. Okay. Therefore, integration over 0 to infinity, only magnitude term consider, t n0 lambda e to the power minus lambda t dt divided by n0, that integral with respect to dt. So, lambda as constant, n0 lambda outside, integration over 0 to t e to the power minus lambda t dt divided by n naught. So, n naught cancelled out, we have lambda zero to infinity t e to the power minus lambda t dt. Let we find out what be the integral value of that one. How to calculate? This is the integration. By parts method is used. Integration by parts is used, lambda here we prefer that one integration, this one as constant. Next, first integrating that term, this term as constant. So, t e to the power minus lambda t divided by minus lambda, and the constant the limits use 0 to infinity minus integration over 0 to infinity, here derivative of that term and integration of this term, derivative of that term e to the power minus lambda t divided by minus lambda This is the integration of this term and derivative of that of t as t, and we integrate it with respect to dt. By parts rule is used, is equal to that lambda, this lambda cancelled out, and again in that term also that lambda. In these two terms 1 by lambda is common and lambda to 1 by lambda cancelled out. So, here it is written like this, lambda to that common 1 by lambda cancel out. So, minus t e to the power minus lambda t using the limit 0 to infinity, here as minus minus plus integration over 0 to infinity e to the power minus lambda t dt, that a limiting value as 0 plus its value e to the power minus lambda t divided by minus lambda and the limit 0 to infinity, upper limit and lower limit is used, minus 1 by lambda, upper limit e to the power minus infinity minus e to the power 0, which is equal to minus 1 by lambda into 1 divided by e to the power infinity e to the power 0 1 e to the power infinity as 0. So, minus 1 into this minus 1 by lambda into 0 minus 1 minus minus plus, that result is 1 by lambda. This is for tau. In final expression we have the mean life is equal to reciprocal of that decay constant. This is equation number 4. Hence, mean life is the reciprocal of the decay constant. Mean life of a radioactive substance is inversely proportional to that of decay constant. This is the expression for mean life, and that one is the expression for half life. So, how mean life and half life both are related? This is an important note. T half is equal to 0.693 divided by lambda, that equation number A, and there tau is equal to 1 divided by lambda. From A and B we get, in place of that 1 by lambda we can substitute tau. So, T half is equal to 0.693 into tau, that is half life is equal to 0.693 into mean life. So, half life 0 is equal to 0.693 times of that of mean life. So, here with the help of this visual lecture we understand the concept of radioactivity, radioactive elements, radioactive decay, some basic properties of alpha decay, beta decay and gamma decay, law of radioactivity mathematically, that is n is equal to n naught e to the power minus lambda t. Graphically we show it, the number of radioactive atoms left after that of time t, mean life, sorry, half life, mathematical expression for that of half life, mean life mathematically, that is the reciprocal of decay constant and the relation between half life and mean life. So, with this useful and informative notes, let me wind up this session. Thank you.